Algebra 1, 5.1, we are going to solve inequalities in this lesson by adding and subtracting. Guys, there's a big difference between an equation and an inequality. An equation uses an equal sign, and inequalities use inequality symbols. So, greater than, less than, greater than or equal to, less than or equal to, as we have stated for below. So, make sure you guys know how or what these are for the fact that this is a less than symbol, while this is a greater than symbol. Back in the day, you might have learned this as an alligator's mouth. It always likes to open to the bigger number. Well, here's the thing, is that now we're going to start putting them into inequalities or equations that represent finding all solutions that would make it true, and so we're going to have to simplify it. And so it doesn't always necessarily come up to the side that looks the biggest. You are going to have to solve it. This is a less than or equal to and greater than or equal to. Now, what we need to realize is that you're going to have to use number lines. So I'm going to have a number line. I'm going to have a number like 5. So if I said x is greater than 5, if I have a greater than symbol or even a less than symbol, I cannot be 5. 5 is not greater than 5. So this does not make sense. That's a bad inequality symbol. So 5 greater than 5 does not, it's not true. It's not work. So what they have here, when you have a number line, I have to have an open circle. And then I have to pick a point. So if I go over here and say, here's 0. Is 0 greater than 5? And you're probably like, no, that's not true. Because 0 is not bigger than 5. If I go over here at 7, I can say 7 is greater than 5, and that's true. So therefore, all my answers or solutions are over here. Now, you don't have to do 2 points to check. You only need 1. And 1, if it's not heads, then it has to be tails. So if it's not on the left side, it has to be on the right side. So that's how I do that. So less than is an open dot, greater than is an open dot. If it's equal to, therefore, they are filled in circles because I can be at that point. So they can be right up to it. So in this problem right here, I can be 5.00000001, but I cannot be 5. So it just has to be just over. Now if this would have said equal to, as in here, then I can be 5 and then greater. So take that in consideration. So the first slide we have here of actually doing some problem is the addition property of inequalities. Basically, whether we have A is greater than B or A is greater than or equal to B, it's the same thing. Basically, the golden rule. If the same number is added to an inequality on both sides, it still is true. What you do to one side, you still have to do to the other. It's the same thing if it's A is less than B. So A plus C is less than B plus C. So if you and your friend have different amounts of money and you have more money than your friend and you guys both get paid equally $20 for raking and cutting a lawn, you still got more money than your friend. It doesn't change that fact. And so the first problems we have up here, and I'm only going to do one because I think it'd be enough, is to solve this. I want to solve for m. So to get m by itself, I have to do the opposite of minus 8, or the inverse. And so therefore, I'm going to add 8 to both sides. 22 plus 8 is 30. I am not going to do anything to inequality symbol, and is m. So 30 is greater than m. Now a lot of us, we like to put m first. So this is m is less than 30 is the same thing. Those are the same. Don't get them mixed up. They mean the exact same thing. So if I go to a number line, I'm going to put 30. I'm going to put an open dot because it's either one. So I'm going to graph the top one because that's the one that we had originally come up with. It says that it's a greater than symbol, but 30 is my anchor point. Now, if I am on a number line, then 0 should be over here. So I kind of mark 0 somewhere. Doesn't matter. Nothing's really a scale. And then I'm going to test it. Is 30 greater than 0? And I think you would say, yeah, that's true. So therefore, I'm going to shade And I usually make a little squiggly line so I can see it. Because a lot of times I've seen kids do this, and then you can't see it. How do I know that's just not a thick line or whatever? So that's why I like to do a squiggly line. So, adding, subtracting, not that big of a deal. Adding in this case. The next group is the same thing. Wait, actually I'm going to go back. The next one is, oh, there's the subtraction property. Let's just talk about this one first, and then I'll go back to that set notation. So don't mind the example here right now with these answers. We'll find that in a second. The idea that just because A is greater than B, if you subtract the same amount from both sides, so again going back to you and your friend, if you guys both have, you have more money than your friend, and let's say you're throwing a ball around, you break the window, and your parents say, hey, each of you guys got to pay $20 to pay for this window, then you both go down by 20, but yet you still would have more money than your friend. Vice versa. Now it still works for greater than or equal to and less than or equal to. Again, what you do to one side, you do to the other. So if I ignore, and let me ignore this for a second, the multiple choice options there, and we just want to solve this. So P plus 8 is less than or equal to 18. So you would know that you would have to subtract 8 from both sides to get rid of a positive 8. So these are gone. So P is less than or equal to 10. So if I go to graph that, I can go to number line. I can put 10. It's a closed dot this time because it's equal to. I'm going to put 0 here because I want to test 0. You keep on testing 0 unless 0 is one of your anchor points. Is 0 less than or equal to 10? And you're like, absolutely. So that I'll shade to that direction. That's how you do that. Going back to this slide that I skipped over. Guys, it's set notation. Set notation, guys, is just basically making brackets and make the straight line in it. So you always start off with a bracket, and then you define the variable that you have. So in the last problem, we had a problem that said m is less than 30. That was our answer from the first example. Now, what we have to do then is we are talking about this variable m. So we say m, and then we draw a straight line. That straight line actually refers to this words right here, such that. And as you can see, I used the wrong variable in here. This is supposed to be m, such that m. So get that out of there. So we're going to use this is such that, and then you put m first as less than 30, and then you close it. That's just set notation. Okay, so it's just putting it in a more formal setting to state your answers. So you know you're talking about the variable m, and that this is the conditions for m. M has to be less than 30. So if I go back to this example, we found that P is less than or equal to 10. So to put this in the set notation, I'm going to put my brackets. I'm talking about variable P such that, and then just write what you just solved for. P is less than or equal to 10. Now if I get the eraser out and bring back our answers, it has to be one of those answers. And it looks like it would be G. P is less than or equal to 10. Notice that they also gave one that was P is going to be greater than or equal to 10. Watch your inequality symbols. Now, the next ones start to get a little bit trickier, but not much. Remember that you can move variables just like you can remove constants back and forth. So what they did is that they put variables on each side. Now, the rule of thumb for me is to always gather up my like terms, get them to the same side. And again, it doesn't matter. I can take and subtract 10n from both sides. And if I subtract 10n from both sides, you better make sure that you put a 0 here. And if I go over here, I know I can move 4n. or 4h, sorry, or 5h. It does not matter. So you can move any one of those variables that you would like to move at any time. Just what you do to one side, you have to do to the other. One rule of thumb that always follow is move the smaller variable. So I'm going to go move smaller variable. So move the smaller variable. That way I'm more likely to keep a positive variable, and I'm pretty much happier with a positive variable. So if I look at this problem, 9n or 10n, I would think 9n is smaller than 10n. So to move it, I'm going to subtract 9n from both sides. 9n minus 9n is gone. Negative 1. Inequality symbol is going to stay the same. 10 of something minus 9 of something leaves me with 1 of something. And guess what? I just solved it. So, set notation would be n such that, now when we put in set notation, we always put the variable first, so it would be n greater than negative 1. And if I had to graph it, I can put a negative 1, it's an open dot, and 0 is over here this time. Is 0 greater than negative 1? Absolutely, shade in that direction, and there you go. The next problem, I'm actually going to move 4h because 4h is smaller than 5h. So minus 4h minus 4h. So h is less than or equal to 12. It's actually got it. So h such that h is less than or equal to 12. Put a number line, put 12. It's a closed dot. And where's h less than? So here's 0. Is 0 less than or equal to 12? Absolutely. Shade in that direction. So it's not too bad. So for your homework, I actually want you to do all 8 problems. They should be good. They should be quick, fast. Solve each inequality. Put the solution on a number line. I would also practice set notation as well. Have a great day.